Here is the video for equilateral triangles and isosceles triangles. So your little picture here with three congruent sides. Okay, so here's our first little problem to look at. It's a word problem with a picture. But if it says equilateral triangle, and it can tell you a couple different ways. It can come out and tell you it's equilateral, or it can also give you those symbols like on the picture on the paper. Now, the reason why this is so hard to find for X for some people is that people like to think that there's only one way to do something, and that is the only way to get the answer. But on this one, there's multiple ways you can do this. If all three of these sides are congruent, that means they're equal to each other, and you have to find the measure of each side. You can find X by any way you want. All you have to do is pick two of these three sides and set them equal to each other. That's how you could find X. So I could easily say that 10x minus 6 equals 7x plus 18. I'm going to pause for 5 seconds, and you can pause the video and solve that for me. Okay, so I got x equals 8. Sorry, let's see. Yeah, x equals 8. And then how would you find the measure of each side? Well, this is equilateral, so all you would need to find is the length of one side. So if I put 8 here and got 80 minus 6 is 74, all these sides are 74, like 74 centimeters, inches, whatever. These aren't degrees, these are lengths. All right, moving to isosceles. The isosceles has two equal sides. So they would have to tell you some way which sides are equal, and they do here. DE is equal to EF. Okay, and the sides here are called legs. Okay, the sides that are equal are called legs. And the side that is not equal is called the base. So the base will have a different length than the legs. So on this particular question, people would find this easier because there is really only one way to find X. You would set these two pieces equal to each other. Okay, so then I would solve for X and get 10. Okay, and then I would just plug it in to all three, knowing that these two pieces better come out to be the same length. And then I can this can be anything at once as long as it's not the same as these two. This could be bigger or smaller as long as it's not the same length as these two up here. So there's working with side lengths. Now working with angles is a lot different. I mean, I guess it's not as different, but here we go. So the two angles that are congruent in an isosceles triangle are called the base angles. And that one angle that is not congruent to the base angles is called the vertex angle. It is not equal to these. Now let me show you an easy way I think is to find the vertex. So here are my markings to show my equal sides. If I go to the corner that's between them two, from those two markings, it makes like a V. And that angle inside that one is always the vertex angle and not equal to the other two. Let me give you an example of that for here. So here's my marking. So I'm going to take both these, go to the same angle. This is the vertex angle that is not equal to these two. Therefore, these two must be equal. So these are the congruent base angles. So how do I find x here? Is that these two are equal, and I add them up to 130. So this must add up to 180 because it's three angles inside of a triangle. Therefore, this guy has to be 50 to make it equal 180. All right, here's an example with exterior angles and the isosceles triangle. So how could I find angle y is? Well, this adjacent angle here has got to be 80 because it makes a half circle. This is my vertical angle. Therefore, it's not equal to these two, and these two must be the same. So those two are 160 together, and therefore this guy has got to be 20 to be the finish off the 180 inside this triangle. Same thing, but we're kind of working inside out now, and I just twisted the triangle a little bit. But here's how we start, is I do want to know that that's my vertical angle. So that means these two are equal to each other. So how can I find my two equal base angles? So that means there is 140 left inside the triangle. And these two must add up to that 140 and be the same. So it's really a 140 divided by 2. Both of these are going to be 70. And then to get W, do a little half circle here, and your final answer will be 110 for W because of this half circles 180. Okay, so a word problem would be the degree measure of the vertex angle 7x minus 27. So the vertex angle is that one that's by itself. The degree measure of each base angle is 90x or 9x minus 34. There's two of those. What's the value of x? So these are inside angles of a triangle, and they add up to 180. So there's going to be 7x minus 27 here. There's also two of these. So really, I'm going to double that. I'm going to double that into 18x. I'm doubling the 9x minus 68. There's got to be two of those. Plus that vertex angle of 7x minus 27. Here's the reason why I was doubling that. Because now I got to create an equation that adds up to 180 because there are three angles inside of a triangle. So double the base angle when it kind of tells you there's more than one because it says each base angle. That means there's going to be more than one. So this is your equation that I would use to solve for x. And then once you do that, you're done. All right, so that was a little short video on how to work with isosceles triangles and equilateral triangles. Remember, on the isosceles triangles, I think a real helpful tool is to make sure no matter where those markings are, on the top, we like it on the top, but if it's down here on the side, make sure you know that this is that vertex angle that is not equal to the other two, and these two would be the same. Use those two markings to find that vertex angle.